The question says that a truck starts from rest and accelerates uniformly at 2 meter per second square at time t equals to 10 seconds. A stone is dropped by the person standing on top of the truck, that is 6 meter high from the ground. What is the velocity acceleration of the stone at t equals to 11 seconds? So here the question is talking about a case where a body detaches from another body that is being accelerated. So let us assume that there are two bodies in contact first, and we are assuming that this body is tight so that no slipping is occurring between these bodies. Now if this body is accelerating with some acceleration, let's say a, the moment body 2 will get detached, it will lose its acceleration. The body 2 will lose its acceleration. Now here the same case is occurring here. Body 1 is the truck and body 2 is the stone. A stone is being thrown by the man. So the moment stone is thrown at 10 seconds, it will lose accelerating and it will go with constant velocity. So we have to find out the velocity at t equals to 11 seconds and acceleration of the stone at t equals to 11 seconds. So let us proceed with the solution. So velocity will have two components. One is horizontal component along the direction of moving of truck, and another would be vertical component along the direction of gravity, acceleration due to gravity or towards the ground. So let us represent it by Vx and by Vy. So Vx would be u plus at. Now u would be, since truck starts from rest, it would be 0 plus acceleration is 2. For how much time the acceleration acted? For 10 seconds. So Vx would be 20 meter per second. Similarly Vy we can calculate u plus at. Now stone is thrown from rest in this y direction, so it would be 0 plus, so for how much time the stone has traveled in air? It would be just 1 second, because at 10 seconds it was stationary in this y direction. So we can use 10 meter per second square for acceleration due to gravity multiplied by 1 second. So its velocity would be 10 meter per second. Now resultant velocity vector, the magnitude of resultant velocity vector can be given as 20 square plus 10 square under root, and that will come out to be 22.4 meter per second square meter per second. Now we have to calculate the direction at which the resultant velocity is acting. So the direction of the resultant velocity vector. Now we can move this velocity vector here, and this would be the resultant velocity vector Vr. Let us represent it by Vr. So we have this Vx of magnitude of 20 meter per second, and Vy has magnitude of 10 meter per second. Now finding this angle theta would give us tan theta, the trigonometric ratio would give us 10 divided by 20. Now theta would be tan inverse of 1 by 2. That will come out to be 26.6 degrees. And also this theta is equals to this theta. So the resultant velocity vector is acting at 26.6 degrees from the horizontal axis. Now we have found out the velocity vector at time t equals to 11 seconds. We have to find out the acceleration of the stone at t equals to 11 seconds. So as we discussed in this picture, that as soon as the body detaches from the accelerating body, the agent that was causing the acceleration with respect to the first body is not acting anymore. So there is no acceleration due to this body. The only acceleration left would be acceleration due to gravity, and it has magnitude of 10 meter per second square in the downward direction. So the net acceleration at t equals to 11 seconds is 10 meter per second square in the downward direction. Thank you.